Well, hello guys, I'm back with the TensorFlow tutorials again, and today what we are going to do is linear regression with TensorFlow. Yeah, of course, like you can do your NumPy methods and stuff like that, but with TensorFlow, it's kind of much more fun and well easier, I guess. Yeah, I mean you can do it with sklearn, but let's just go with this one. Well, import NumPy as np, and well after that, I'm gonna use some libraries which you're not gonna like, but this is for you guys. 10 for stf, and then yeah, import matplotlib dot py plot as plt, and then import matplotlib dot mpatches as mpatches, and then plt. I'm gonna like define a plot size. All right, let me just restart this console because yeah, plt.rc params. What does is like set the size of the output that I'm gonna get, because normally it's very small, and since you guys can't see much in this one, I think 10 comma space 6, it's by 10 centimeter by 6 centimeter, so x equals to np dot a range. I'm gonna create some data for you. 0, 0.0. You know what guys, I'm gonna take a small shortcut for you. What I'm gonna do is x underscore data. I'm gonna create some data for you. X underscore data equals to np dot random, and well, I'm gonna random what? I'm gonna random from 100 numbers. Well, as type np dot float 32. So it's like having a float with 32 bits, and then what y underscore data is it is equal to x underscore data into 3 space plus 2. So this is like a line that we are trying to plot, and well, I'm gonna do some more stuff. I'm gonna vectorize it. You need to like sort of brush up your numpy if you're gonna go through this one, and then y for y plus np dot random dot normal. I wish I could explain all these parameters, but well, you can check these out in the NumPy documentation. It would be much easier for you and for me. And well, y underscore data. And now we start building. Well, it's good to write comments because well, you can remember what you did in your program. Variable tf dot, and what x is going to be is like I'm just initializing these. Like you can have it from 100 to anything, but I'm keeping it 1, and well, let's just say zero point 0.2. Now what I need to do next is y is equal to 8 times x underscore data plus b. Now this is going to create some y modules for us. Now creating loss and optimizing. I'm going to tell you what it is by quick. Now loss equals to tf dot reduce underscore mean, and well, what are you going to reduce the mean of? I'm going to reduce the mean of the squares, tf dot square of y minus y underscore data. Yeah, got it. Well, what we got the answer and what the answer actually was, we are gonna reduce that. And well, for optimizer, well, TensorFlow has a built-in optimizer. It's called gradient descent optimizer. You can use other optimizers as well, but like every optimizer has a different function. And for linear regression, gradient descent optimizer performs good. uh, to check out which optimizer performs well, you can kind of work on types of optimizer, like keep changing the types of optimizers and see where you get the best results. Yeah, So what we are going to do here is optimizer equals to tf.train gradient descent optimizer, and then like train. What are we supposed to train? We are supposed to train the optimizer to minimize what? To minimize the loss. And after this, well, now our step of tf dot global variables initializer. Without this, nothing works. And then after that, tf.session as sus. It's just an alias name, sus.run, and then we'll initialize all the variables for me, man. And then we are gonna see what happens. So for that, I'm gonna create a chain data where it's gonna store what's happening where. So for step in range of 100, so like I'm gonna try to run this program 100 times. So it's gonna be quite fast, don't worry. Now eval equals to sys dot run, and we'll train our optimizer, of course, a comma space b, and then well from 1 to all. And after this, if this is just for our printing purpose, like you could print everything like after every step, but I would like to see what happens after every 5 steps, because it would kind of get cluttered. So print step comma evals, like after every step what is the evaluation, and well I'm gonna store that into a train data array, which is like gonna be used later. So after this, guys, I'm gonna take a piece of code because I don't want to lengthen this video. Yep, got it. Now okay, sorry. Yeah. Uh-huh. Uh-huh. Yep, got it. This is just for plotting purposes so that you guys can see what's happening every time. So let me just initialize all the data. Wait a second. Okay, sorry, it wasn't m patches, it was patches. Okay, let me try again. So here we have created x data, here we have created y data. Alright, now y data. So after that we are initializing a and b. Well, these are not going to be initialized until and unless our session runs. And after that, yeah, now our session starts to run, and well I'm gonna run this whole piece of code. Now let us see. Yep, we got the results very quickly, and our variables here over here, blah blah blah. So yeah, initially we started with 1.0 and zero point 0.2, and after 5 steps it realized that no, this is wrong, mate, and it's 2.45. Like A should be 2.45 and B should be 2.3. After 10 steps, it improvised. After 15, it improvised further. After going at around 2.988, it went to 2.9896661. So it was roughly close to, as you can see, it's around 3, and this is around 2, which we initially planned it for. So this is the initial line that we gave it, and these are all the lines that it got itself trained to. And like as you can see, this is the perfect red line. Well, this particular red line is what is our final result. So I hope you guys enjoyed this. If you have any doubts, please leave in the comment section below, and I'll try to answer all of them. Thank you very much, and enjoy TensorFlow.